Welcome back to the Bedtime Science Stories channel. Find a comfortable position, let your body relax, and allow your mind to gently settle. Tonight we begin a new journey, exploring distance. Not distance as a number on a screen or a line on a map, but distance as you experience it. The kind of distance that takes time, effort, memory. You live inside a world where most distances make sense. You walk them, you drive across them, you fly over them and arrive within the span of a single day. Your mind is well adapted to a universe where places are reachable, where journeys have a beginning and an end you can imagine. And within that scale, everything feels stable. Ground beneath your feet. A horizon that feels far but not unreachable. A sky that seems vast, yet familiar. At this level, your intuition works beautifully. It tells you what is near, what is far, what can be reached and what cannot. But tonight, without rushing and without forcing understanding, you allow that scale to slowly change. Not to make the universe feel overwhelming. Not to strip meaning away from the human world. Only to gently expand your sense of proportion. Because this is not a story about being small. It is a story about learning where you truly are in a universe shaped by distance, time, and light. And as this journey unfolds, one calm step at a time, you may find that understanding distance also changes how you understand yourself. You begin in a world where distance feels reasonable. You wake up, stand up, and place one foot in front of the other. Walking is the most basic way you measure space. Each step has weight. Each movement takes time. Your body becomes the measuring instrument, translating distance into effort and rhythm. A short walk feels light and forgettable. A long walk leaves warmth in the muscles and a quiet sense of having traveled somewhere, even if the destination is ordinary. Driving extends that scale without breaking it. You sit still, yet the landscape moves. Roads pass beneath you in steady lines. Minutes turn into miles, miles into hours. You understand this kind of distance because it fits neatly into your sense of time. You know how long a commute feels. You remember road trips not in kilometers but in songs played, conversations shared, and moments of silence while watching the horizon slide by. Flying stretches distance further, but still keeps it within reach. You rise above the ground, cross states, oceans, even continents in a single day. From the air, cities shrink. Rivers curve like lines drawn by hand, and mountains flatten into texture. Yet the journey remains understandable. You leave in the morning, you arrive before night. Your body accepts the idea because the timeline still makes sense. These are distances you can imagine, because they are distances you can complete. Your brain is built for this kind of world. Neuroscience shows that human spatial intuition evolved in environments where movement mattered for survival. Finding food, returning home, remembering paths, avoiding danger. Distance was never abstract. It was always connected to action, how long it takes to get there, how tired you will be when you arrive, whether the journey is worth it. Time and distance are tightly linked in your experience. You rarely think of one without the other. A place is not just far or near. It is 15 minutes away, 2 hours away, a full day of travel. Distance becomes a story told through duration. Memory reinforces this connection. You do not remember distances as numbers. You remember them as experiences. The long walk home in the rain. The drive that felt endless because you were anxious. The flight that seemed short because you slept through most of it. Distance is stored emotionally, not mathematically. This is why maps feel intuitive. A map does not just show where things are. It quietly suggests how reachable they might be. A line between 2 points carries an unspoken question. Could I go there if I wanted to? Your mind answers based on effort, time, and familiarity. Space rarely gives us simple answers. Even in your daily life, distance is never just physical. It carries meaning. The distance between two homes can feel small if you visit often. It can feel enormous if you have not traveled it in years. Emotional distance stretches and contracts independently of geography. Yet your brain treats it using the same internal tools. This blending of space, time, and memory works because the world you evolved in is limited. Earth is large, but not incomprehensible. You can cross it. People have done so for thousands of years using nothing more than walking, sailing, and patience. At this scale, your intuition is reliable. You can estimate. You can plan. You can imagine the journey before it begins and recognize it when it ends. But something subtle is happening beneath this comfort. Your sense of distance only works well inside a world of reachable paths. It depends on the idea that space is something you move through, step by step, hour by hour. The moment distance stops being a journey and becomes a separation that cannot be crossed, intuition begins to weaken. Even now, in ordinary life, you may notice this limit. Think of a place you know exists but have never visited. A small town you have heard of, but cannot picture. A remote island you have seen on a map, yet cannot imagine standing upon. The distance feels vague, almost unreal. Not because it is far, but because it lacks personal reference. Your brain does not truly understand space. It understands movement through space. This is why numbers alone rarely help. Saying that something is 100 kilometers away tells you very little unless you translate it into time, into effort, into experience. Numbers whisper more than they speak. When you walk, you feel distance in your legs. When you drive, you feel it in attention and fatigue. When you fly, you feel it as a shift in time zones and light outside the window. Every familiar journey gives your mind anchors, landmarks, milestones, progress. Remove those anchors and distance becomes strangely empty. Silence is also a kind of data. You are not aware of it yet. But even in these comfortable examples, your intuition is quietly making assumptions. That space is filled with landmarks. That travel produces feedback. That movement always results in arrival. That distance exists to be crossed. These assumptions hold true on Earth. They are reinforced every day of your life, but they are not universal. For now, you remain in the human scale. A scale where distance behaves politely, where effort leads somewhere, where memory and motion stay aligned, where your brain feels at home. This is the foundation from which everything else will unfold. And as you rest here inside distances you can walk, drive, and fly, it becomes clear that understanding space has always begun with the body, long before it ever reached the stars. You remain on Earth, but the scale quietly shifts. Distance is no longer measured in steps or short drives. It stretches beyond neighborhoods and cities, beyond the edges of what your daily life normally contains. You begin to think in terms of continents, vast land masses separated by oceans, places that require planning rather than impulse. A journey across a continent is still imaginable, but it carries a different weight. You know it will take days rather than hours. You know that landscapes will change, climates will shift, and familiar reference points will slowly disappear. Yet your mind can still follow the path. Highways connect cities. Airports connect regions. The journey unfolds in stages you can name and remember. You might picture crossing North America from coast to coast, the steady movement from east to west or north to south. Time zones change. The light outside the window behaves differently. Morning arrives earlier or later than expected. Your body notices before your thoughts do. Sleep adjusts, meals drift, distance announces itself through time. This is where distance begins to feel less like motion and more like duration. The science behind this perception is simple and deeply human. Your brain does not store the Earth as a sphere floating in space. It stores it as a network of routes, stories, and experiences. Each long journey becomes a stitched sequence of smaller, manageable segments. When the segments are clear, distance remains understandable. Flying across an ocean is long, but it is still a single night. You board, you wait, you sleep or stare into the dark. You arrive. There is no mystery in the middle, only time passing quietly. Numbers whisper more than they speak. Even the size of the Earth itself feels manageable in this way. The planet's circumference, about 40,000 kilometers, is a large number, but it does not feel overwhelming. You know people have traveled it. Ships have circled it. Aircraft can cross it in less than 2 days. The Earth reveals its scale gradually, without resistance. From a scientific perspective, this is an important threshold. The Earth is large enough to challenge human endurance, yet small enough to remain within human narrative. You can tell stories about traveling around it. You can draw maps that feel complete. You can imagine standing on opposite sides and still feel that you are part of the same place. This is why the idea of circumnavigation feels meaningful. To go all the way around something implies understanding it. Completion, closure. The Earth allows this illusion. It invites you to believe that space can be mastered by persistence. And for most of human history, this belief was enough. Even long, difficult journeys remain grounded in expectation. You know that if you keep going, you will eventually reach land. You know that distances shrink once they are measured, timed, and recorded. The unknown becomes known through repetition. Space rarely gives us simple answers. At this scale, distance still behaves like a promise. It may take effort, patience, and coordination, but it leads somewhere. It ends. The planet's surface is continuous. There are no gaps where travel simply stops making sense. Yet something subtle begins to change here. When you look at a globe, you see the entire Earth at once. Continents appear close together. Oceans seem smaller than they feel in reality. The map compresses experience. Distance loses texture. 1,000 kilometers becomes a short arc. 10,000 becomes half a circle. Perspective begins to distort intuition. Your brain accepts the image, but your body knows better. This tension between representation and experience is the first quiet fracture in how you understand distance. The Earth looks small when you step back. It feels vast when you move across it. Both are true, and your mind holds them together without conflict because movement still connects them. Silence is also a kind of data. You may not notice it, but your sense of scale is already being trained. You are learning to accept larger distances without anxiety. You are learning that space can be wide and still familiar. That time can stretch and still remain meaningful. This preparation is unintentional but essential, because there is a limit to journeys that remain imaginable. The Earth marks the upper boundary of a world where distance is still tied to effort, where speed can compensate for scale, where human technology can close the gap between departure and arrival without changing the nature of time itself. Beyond this boundary, distance stops behaving like a journey and starts behaving like separation. For now, you remain safely within the long but understandable paths of your home planet. Continents may feel far apart, but they still belong to the same story, the same sky, the same day and night. As you rest with this idea, it becomes clear that Earth is not just where you live. It is the largest space your intuition truly knows how to navigate. You leave the surface of Earth without yet realizing what has changed. At first, the moon feels close. You have seen it your entire life. It rises and sets with quiet regularity. It hangs in the same sky as airplanes and clouds. Its surface details are visible to the naked eye. Familiarity makes it feel reachable. Then the number appears. 384,000 kilometers. On Earth, a number like this still belongs to travel. It suggests a long journey, but not an impossible one. Your mind reaches for reference points, long highways, circumnavigations, multiple trips around the planet. Numbers whisper more than they speak. But the path from Earth to the Moon does not behave like any journey you know. When the Apollo spacecraft traveled to the Moon, it did not follow roads or routes. It moved away from Earth into a region without landmarks. The trip took about 3 days, not because the distance was enormous by cosmic standards, but because speed had limits, fuel had limits, and human bodies needed controlled motion. 3 days does not sound long. You have experienced longer flights, longer drives, longer waits. Yet these 3 days unfolded in a fundamentally different environment. There was no changing scenery, no sense of passing through intermediate places. Earth shrank steadily behind them and nothing replaced it. This is where intuition begins to fail. On Earth, distance is divided into segments. You pass towns, borders, landscapes. Progress is visible. Between Earth and the Moon, there is only separation. The spacecraft leaves one world and heads toward another, suspended in a vast region of near emptiness. Space rarely gives us simple answers. Even communication behaves differently here. Radio signals travel at the speed of light, yet they are no longer instantaneous. A message sent from Earth to the Moon takes about 1¼ seconds to arrive. The reply takes just as long to return. For the first time, conversation gains a pause that cannot be removed. This delay is small, but it matters. It breaks the illusion of immediacy. You speak, and the universe does not answer right away. Silence appears, not as a malfunction, but as a feature of distance. Silence is also a kind of data. For the astronauts, this delay was subtle but constant. Instructions were not conversations. Questions did not receive immediate reassurance. Every exchange carried a reminder that they were no longer within the seamless human world of instant response. Your brain is not built for this. Human intuition assumes feedback. When you act, you expect a reaction. When you speak, you expect a reply. These expectations are deeply embedded in how you perceive space and safety. The Moon quietly violates them. The distance itself, 384,000 kilometers, does not feel large until you try to imagine the space between. There are no cities, no mountains, no weather, no sound. Just a thinning of Earth until it becomes a small, bright disk, and a growing awareness that nothing lies between. The emptiness matters more than the number. On Earth, emptiness still has structure. A desert has dunes, an ocean has waves. Even the sky has clouds and color. Between Earth and the Moon, emptiness has no features your mind can hold on to. There are no natural reference points to mark progress. This is why diagrams are misleading. They show a line connecting Earth and Moon, as if space were a corridor. In reality, it is a volume. A three-dimensional region where direction loses meaning without constant correction. The spacecraft does not travel toward the Moon so much as it falls sideways around Earth, guided by gravity. Motion here is mathematical, not intuitive. You do not go straight, you follow curves defined by invisible forces. Numbers whisper more than they speak. The Moon becomes visible long before it feels near. It grows slowly, almost reluctantly, offering no sense of approach. Your intuition expects arrival to feel different. It does not. This mismatch is the first real fracture between human scale and cosmic scale. The Earth-Moon distance is small enough to cross, yet large enough to expose the limits of human perception. It shows that distance can exist without journey, that time can pass without experience, that space can be real without being meaningful to the senses. From a scientific standpoint, this distance is modest. Light crosses it in just over a second. From a human standpoint, it is profound. It introduces delay, isolation, and the awareness of true separation. Apollo did not just travel to the moon, it revealed that space is not an extension of Earth. It is a different environment with different rules. For the first time, distance stops being something you traverse and becomes something you endure. As you rest with this idea, it becomes clear that the moon is not important because it is far, but because it is empty between. It is the first place where your intuition learns that space does not exist to be crossed for your comfort, only to be measured and respected. Once distance leaves the surface of Earth, it begins to change its character. It is no longer defined only by how far something is, but by how long it takes for anything to happen. Space introduces slowness in a way that cannot be avoided or rushed. Even at the speed of light, nothing arrives immediately. The universe does not offer instant response. On Earth, delay usually means inconvenience, a slow connection, a late reply, something that could be fixed with better technology or more effort. In space, delay is not a flaw, it is built into reality itself. When you send a signal across distance, it moves as fast as nature allows. There is no faster option waiting to be invented. Information travels at a finite speed, and that speed sets a limit that cannot be negotiated. This is the first time distance truly becomes time. Between Earth and the Moon, the delay is just over a second. Small enough to tolerate, yet large enough to notice. Between Earth and distant spacecraft, that pause grows longer. Minutes, hours, sometimes longer. Conversation becomes instruction. Dialogue becomes sequence. Space rarely gives us simple answers. Your brain, however, expects immediacy. Human perception evolved in environments where cause and effect occur close together. You speak and hear a reply. You move and feel resistance. You look and see light reflected instantly. This tight loop of action and response forms the foundation of intuition. Space quietly breaks that loop. When feedback disappears, uncertainty appears. Not dramatic uncertainty, but a subtle awareness that nothing is happening right now. The signal has been sent, the action has occurred, the response is still traveling. Silence is also a kind of data. In space exploration, silence is not empty. It is measured. It is predicted. Engineers know exactly how long a signal should take. Astronauts and mission controllers wait not with anxiety, but with patience shaped by physics. The pause itself carries information about distance. This changes how humans interact with machines, with missions, and with one another. Decisions must be made in advance. Errors cannot be corrected instantly. Control gives way to planning. From a scientific perspective, this slowness is not accidental. It emerges from the structure of space-time. The finite speed of light ensures that the universe remains causal. Events influence one another in sequence, not all at once. There is no universal now that everything shares. Each location carries its own present. This idea feels abstract, yet you experience it every time you wait for a reply from space. When a spacecraft sends data back to Earth, it is reporting on something that has already happened. By the time you receive the information, the moment itself is gone. Numbers whisper more than they speak. Distance transforms action into memory before it arrives. This is difficult for the human mind to accept because it removes the sense of control. You are no longer acting in real time. You are interacting with echoes, with signals that represent the past rather than the present. In everyday life, silence often feels uncomfortable. It invites interpretation. In space, silence is neutral. It is expected. It is part of the measurement. There is no urgency in the universe. Stars do not hurry to respond. Planets do not acknowledge observation. Space unfolds according to physical laws that operate without regard for attention or impatience. The absence of immediacy does not mean absence of connection. It means connection exists on a different timescale, one that is larger than instinct, larger than reflex. As distance grows, the waiting grows with it. What begins as a pause becomes a gap. What begins as a delay becomes a separation between cause and awareness. This is the quiet lesson space offers early. That not everything happens when you are ready to notice it. That understanding often arrives after the moment has passed. You remain connected to distant places not through presence, but through patience. And as you rest with this idea, it becomes clear that distance is not just about how far something is, but about how long the universe asks you to wait before it answers. You look at the sun and everything feels immediate. It rises in the morning, it warms your skin, it lights the day without hesitation or delay. Of all celestial objects, the sun feels closest, most reliable, most present. It shapes daily life so completely that you rarely think of it as distant. Then the number appears. About 150 million kilometers. At this point, the number no longer helps. It does not connect to walking, driving, or flying. It does not suggest effort or endurance. It simply exists, detached from experience. Numbers whisper more than they speak. Instead, distance reveals itself through time. Light leaves the surface of the sun and travels through space for a little more than 8 minutes before it reaches Earth. 8 minutes is not long. You have waited longer for a traffic light to change. You have waited longer for a message to send. Yet this small delay quietly changes everything. When you see the sun, you are not seeing it as it is right now. You are seeing it as it was 8 minutes ago. This is not a metaphor. It is a physical fact. The sunlight touching your eyes began its journey long before you noticed it. If the sun were to suddenly change, you would not know immediately. The information would still be traveling. The universe does not provide real-time updates. Space rarely gives us simple answers. On Earth, light feels instantaneous because distances are small. You flip a switch and the room brightens. You look across a field and see it clearly. The delay exists, but it is too short for your senses to register. Your brain learns to treat light as immediate. The sun breaks that assumption gently, without drama. 8 minutes is long enough to matter, yet short enough to ignore. You live your entire life under a star you are always seeing slightly late. This delay does not change your safety or your routine, but it introduces a profound idea. Observation is always backward-looking. You never see events as they happen. You only see them after light has had time to reach you. Silence is also a kind of data. From a scientific perspective, this delay is not special. Light travels at a constant speed. That speed is the same everywhere, for everyone. The sun is simply far enough away for the delay to become noticeable. The distance itself becomes secondary. 150 million kilometers loses meaning. 8 minutes becomes the true measure. Time replaces space as the unit your mind can grasp. This is where distance fully transforms into information delay. Every observation you make of the sun carries this quiet truth. Solar flares, sunspots, changes in brightness, all of them are records of the recent past. By the time you become aware of them, they are already over. You are always reacting, never witnessing. This may sound unsettling, but it is not a flaw. It is how the universe functions. Light is not a messenger designed for convenience. It obeys physical limits that apply equally to stars, planets, and people. Your brain, however, still expects immediacy. You look up and feel that the sun is there, now. Intuition resists the idea that you are living under a constant delay. Yet science insists quietly and consistently. This gap between perception and reality widens as distance grows. The sun becomes the first object where you regularly experience cosmic delay without noticing it. You live comfortably with this contradiction because the timescale remains manageable. 8 minutes is short enough to blend into daily life, but the lesson is already planted. Information takes time. Presence is never guaranteed. Distance is not empty space, but a stretch of waiting that cannot be shortened. Numbers whisper more than they speak. The sun also reveals another shift. Unlike the moon, you do not travel toward it. You do not imagine the journey. The distance is not meant to be crossed. It exists as separation, not path. The sun influences you across space without physical contact. Gravity, light and energy reach you without movement on your part. You remain still and the universe acts upon you. This is a new kind of relationship with distance. One where motion is not required for connection. One where cause and effect are separated by time rather than effort. From a human perspective, this feels passive. You receive warmth, light, and life without traveling anywhere. Yet even this passive connection obeys delay. The warmth you feel now began as nuclear reactions deep inside the sun long before you noticed them. Energy takes time to escape the sun's interior, and then more time to cross space. What sustains you today began its journey long ago. Silence is also a kind of data. The sun teaches you that the present moment is layered. What you experience as now is a blend of different pasts arriving together. Light from the sun, light reflected from the moon, signals bouncing through the atmosphere. All slightly out of sync, yet perceived as one. Your senses merge these delays into a single experience and call it reality. This is why distance feels invisible until science points it out. The universe does not announce delay. It simply operates within it. As you rest with this idea, the sun becomes more than a source of light. It becomes a reminder that the universe communicates patiently, never instantly, always on its own schedule. And in that steady 8-minute pause, you begin to sense that understanding space is less about how far things are, and more about how long the universe takes to let you know they exist. At a certain scale, familiar units stop working. Kilometers are useful when distance can be connected to movement. They make sense when you can imagine roads, borders, or orbits. On Earth, and even between Earth and the Moon, kilometers still suggest effort and time. They carry the quiet promise that a journey exists, even if you never intend to take it. Beyond that, the unit begins to fail. When you say that the sun is 150 million kilometers away, the number does not clarify anything. It does not make the distance feel larger or smaller. It does not improve understanding. It simply grows without adding meaning. Numbers whisper more than they speak. This is not a problem with the universe. It is a limitation of the human mind. Your brain does not experience space as an abstract grid. It experiences change, motion, duration. When numbers grow beyond lived reference, they stop being informative. They become symbols rather than measurements. Science noticed this long before spaceflight existed. Astronomers realized that adding zeros did not bring clarity. Saying that a star is trillions of kilometers away does not make it more understandable than saying it is millions of kilometers away. Both feel equally unreachable. At that point, a new unit becomes necessary. The light year does not appear because scientists enjoy complexity. It appears because it restores meaning. It replaces distance with time. It answers a more useful question. How long does information take to travel? A light year is the distance light travels in 1 year. It is not a unit of time, but it is built from time. It uses a constant of nature, the speed of light, as its foundation. This choice is not arbitrary. Light's speed is the same everywhere. It does not depend on roads, engines, or technology. It belongs to the structure of the universe itself. Space rarely gives us simple answers. By measuring distance this way, astronomy aligns measurement with perception. You no longer ask how far something is in terms of motion. You ask how far back in time you are seeing it. Distance becomes delay. Separation becomes history. This shift changes how the universe is understood. A star 1 light year away is seen as it was 1 year ago. A galaxy 10 million light years away is seen as it was 10 million years ago. The number now carries meaning because it connects directly to information, to observation, to what you can actually know. Silence is also a kind of data. This unit works because light is not just illumination. It is the fastest messenger available. Every image, every spectrum, every signal from space arrives carried by light. Measuring distance in light years means measuring how long the universe keeps you waiting before it speaks. Kilometers cannot do this. Kilometers describe separation in space, but they ignore the cost of communication. They assume immediacy that does not exist. At cosmic scales, this assumption becomes misleading. It suggests that distance is simply a larger version of what you already know. It is not. The light year introduces a boundary. It reminds you that nothing crosses space instantly. That observation is always delayed. That knowledge arrives late by definition. This is why astronomers rely on natural constants. When human experience fails, nature provides a stable reference. The speed of light does not change with context. It does not care about intention or effort. It remains fixed. Using it as a ruler anchors cosmic measurement to something universal. Numbers whisper more than they speak. This approach also removes the illusion of travel. Kilometers tempt the imagination. They invite you to picture motion. Light years resist that impulse. They do not suggest journeys, they suggest waiting. To say that a galaxy is 100 million light years away is to say that you are looking 100 million years into the past. There is no road implied, no vehicle, only time layered across space. From a human perspective, this feels abstract at first, but over time it becomes intuitive. You stop thinking about how to get there and start thinking about when the light left. This is a more honest relationship with the universe. The light year also reveals something else. Distance is not just separation. It is limitation. It defines what can be known and when. It sets a horizon on certainty. The farther you look, the older the information becomes. The universe does not hide this fact. It displays it openly. Every distant object carries its own timestamp. Silence is also a kind of data. Kilometers fail because they belong to a world where space is small and time is shared. Light years succeed because they belong to a universe where space is vast and time is fragmented. By adopting this unit, science does not make space more complicated, it makes it more truthful. As you rest with this shift, it becomes clear that measuring the universe is not about counting distance, but about accepting delay. And in doing so, you begin to understand that knowing where something is also means knowing how long ago it was there. Light feels effortless. It fills rooms instantly. It reveals the world without asking permission. You open your eyes and vision appears. For most of human history, light seemed infinite in speed, a perfect messenger that connected events without delay. The idea that light might take time to travel felt unnecessary, even strange. Yet the universe does not move instantly. Light travels at a fixed speed. about 300,000 kilometers per second. This number is precise, measured carefully, confirmed repeatedly. It is not approximate, it is not negotiable, it is one of the fundamental constants of nature. This speed is incredibly fast by human standards. It can circle Earth more than 7 times in a single second. It can cross the distance to the Moon in just over a second. It can reach the Sun in 8 minutes. And still, it is not infinite. Numbers whisper more than they speak. For a long time, this limit was invisible. On Earth, distances are too small for the delay to matter. Light crosses a room faster than nerves can react. It crosses continents faster than clocks can notice. Your senses learn to treat it as immediate. The first crack in this assumption appeared quietly, without drama. In the 17th century, the Danish astronomer Ole Romer studied the motion of Jupiter's moon Io. He noticed something subtle. The timing of Io's eclipses changed depending on Earth's position relative to Jupiter. When Earth moved farther away, the eclipses appeared later than predicted. When Earth moved closer, they appeared earlier. At first glance, this made no sense. The Moon's orbit had not changed. Jupiter had not moved unexpectedly. The only thing that had changed was the distance light had to travel. Romer realized that light was not arriving instantly. It was taking time to cross space. The delay was small but measurable, and it followed a pattern that matched Earth's changing distance from Jupiter. This was the first experimental evidence that light has a finite speed. Space rarely gives us simple answers. Romer did not measure the speed of light precisely. He did something more important. He showed that the universe contains delay at its core, that observation itself is shaped by distance, that even the act of seeing is constrained by physics. This discovery changed how science understood reality. Light was no longer just illumination. It became a carrier of information moving at a maximum speed, a speed that nothing could exceed. As measurements improved over centuries, the speed of light emerged, not just as a property of light, but as a limit of the universe. Signals, forces, causation itself, all are bound by this speed. Nothing travels faster. This limit introduces structure into reality. It ensures that events unfold in order. That causes precede effects, that the universe does not collapse into simultaneity. Silence is also a kind of data. When light takes time to travel, absence becomes meaningful. If a signal has not arrived yet, it does not mean nothing happened. It means you are still waiting. The universe teaches patience through physics. This delay is not a flaw. It is a stabilizing feature. Without it, there would be no sequence, no history, no before and after. Time itself would lose coherence. From a human perspective, this feels restrictive. You want immediacy. You want response. You want confirmation. Space offers none of these on demand. Instead, it offers consistency. The speed of light is the same everywhere. It does not depend on motion. It does not depend on the observer. No matter how fast you travel, light always moves away from you at the same speed. This counterintuitive fact has been confirmed countless times. It means that the universe has chosen a speed that all observers must share. This constancy forces time and space to adjust. Clocks tick differently depending on motion. Lengths contract. Simultaneity breaks. These effects are real, measured, and unavoidable. Yet they remain gentle at everyday speeds. Your life unfolds comfortably without noticing them. Only when distances grow large does the limit reveal itself clearly. Light does not bend to expectation, it follows rules written into space-time. When you observe something far away, you are not accessing its present. You are receiving a delayed message constrained by this universal speed. Numbers whisper more than they speak. This realization reframes everything you see in the sky. Stars are not points of light existing now. They are records of nuclear reactions that occurred long ago. Galaxies are not distant objects waiting to be reached. They are histories still arriving. Even emptiness becomes meaningful. If nothing arrives, it may simply mean the light has not reached you yet. Silence is also a kind of data. Light teaches you that limits are not obstacles. They are definitions. They shape what is possible. They give the universe its structure and coherence. There is comfort in this. The same rule applies everywhere. The same delay affects all observers equally. No place is privileged. No moment is absolute. As you rest with this idea, the speed of light stops feeling like a number and starts feeling like a boundary. A quiet line the universe does not cross. And in that boundary, you begin to sense that understanding space is not about overcoming limits, but about learning to live within them, patiently, precisely, and with attention to the time it takes for truth to arrive. You begin with a second. A single light second is the distance light travels in 1 second, about 300,000 kilometers. This sounds large, but it remains anchored to something you know. A second passes easily. You blink, you breathe. Time moves without effort. In that 1 second, light can circle Earth more than 7 times. It can cross continents. It can connect distant cities instantly by human standards. At this scale, light still feels generous, fast, cooperative. A light second still belongs to intuition. Then the scale quietly expands. A light minute is 60 light seconds. Light now travels 18 million kilometers. This is the distance between planets at their closest approach. It reaches from Earth to Mars when conditions are favorable. The Sun is still within reach in less than half this time. At a light minute, distance begins to stretch but not break. You can still imagine waiting a minute. You can still imagine a signal arriving. Time remains familiar. A light hour is different. In 1 hour, light travels more than 1 billion kilometers. This is no longer a distance you can picture as movement. It spans much of the inner solar system. It reaches beyond the orbit of Saturn. It crosses regions that spacecraft spend years navigating. Numbers whisper more than they speak. Spacecraft make this contrast clear. Voyager, launched in the late 1970s, is one of the fastest objects humans have ever built. It travels at tens of kilometers per second. Even at this speed, it takes hours for light to do what Voyager takes months or years to approach. Cassini, which studied Saturn in detail, spent years traveling to its destination. Light reaches Saturn in a little over an hour. The gap between human motion and natural limits grows quietly, without spectacle. Space rarely gives us simple answers. A light day expands this difference further. In 24 hours, light travels about 26 billion kilometers. This distance extends far beyond the planets. It reaches the outer edges of the Sun's influence. It spans a region so vast that spacecraft become nearly stationary by comparison. At this point, motion loses relevance. Distance is no longer about travel. It is about communication. Signals sent to distant probes take hours to arrive. Commands must be planned in advance. Feedback returns long after decisions are made. Exploration becomes patient by necessity. Silence is also a kind of data. A light year completes the transformation. In 1 year, light travels about 9.46 trillion kilometers. This number is precise yet meaningless without translation. You cannot imagine kilometers at this scale. Your mind releases them. Instead, you return to time. 1 year is familiar. Seasons change. Earth completes an orbit. Life continues at a human pace. To say that something is 1 light year away is to say that the information you receive left 1 year ago. distance becomes history. The nearest star beyond the Sun is a little over 4 light-years away. This means that when you look at it, you are seeing light that began its journey before recent memories formed, before some conversations happened, before small changes in your own life. This does not feel dramatic. It feels quiet. Light years do not announce themselves. They accumulate gently. Each additional year adds another layer of delay, another slice of the past arriving now. Space rarely gives us simple answers. At this scale, spacecraft fade into insignificance. Voyager has traveled for decades and has not reached a single light day from Earth. It moves bravely, persistently, yet remains deeply local compared to light. This is not a failure of engineering. It is a reflection of scale. Human machines are designed for nearby space. Light defines the boundary of the universe's pace, not human ambition. Measuring distance in light years acknowledges this difference without judgment. Numbers whisper more than they speak. 9.46 trillion kilometers sounds overwhelming, but it does not overwhelm you. It dissolves. Your brain does not resist because it does not engage. The light year succeeds precisely because it avoids confrontation with intuition. It asks you to accept delay instead of distance. When you hear that a galaxy is 1 million light years away, you do not imagine travel. You imagine time. 1 million years of waiting, compressed into a single moment of observation. The universe speaking slowly, but consistently. This reframing matters. It changes how you relate to the sky. Stars are no longer objects waiting to be reached. They are messages still arriving. Galaxies are not destinations, they are archives. Silence is also a kind of data. Between light seconds and light years lies a continuous expansion of patience. Each step removes another layer of immediacy. Each scale teaches you that the universe operates without urgency. There is no sudden break, no dramatic threshold. Just a steady widening of delay until the present dissolves into layers of past light. This is where many people expect awe or fear. Instead, what often arrives is calm. The light year does not threaten you. It does not diminish you. It simply situates you within a larger timing system, one where meaning is carried by consistency rather than speed. As you rest with this idea, the vastness of 9.46 trillion kilometers softens. It becomes a rhythm, a year of light moving patiently through space. And in that rhythm, you begin to sense that distance is not something to overcome, but something to listen to, quietly as the universe takes its time reaching you. You step outside at night and look up. The sky feels immediate, present, alive. Stars appear steady, fixed in place, quietly watching. Their light seems to belong to the moment you are standing in. Yet the moment you look at a star, you are not seeing it as it is now. You are seeing it as it was. Every star in the night sky is a message that has already been sent. Sirius, the brightest star visible from Earth, lies a little over 8 light years away. The light entering your eyes tonight left Sirius more than 8 years ago. At that time, the world was slightly different. Conversations were unfinished. Small events had not yet occurred. The star you see belongs to that earlier moment. 8 years is not long. Your mind accepts it easily. Memory still reaches that far. Vega is farther, about 25 light years away. The light you see from Vega tonight began its journey before many recent changes in your life, before routines shifted, before familiar moments quietly passed. Then there is Betelgeuse. Betelgeuse is a red supergiant star hundreds of light years away. Estimates vary, but its light takes centuries to reach Earth. When you look at Betelgeuse, you are seeing a star as it existed long before modern technology, before recorded history in many parts of the world. The sky becomes a layered archive. Space rarely gives us simple answers. Astronomy does not offer a single present moment. It offers many pasts arriving together. Each star carries its own timestamp, determined by distance and the speed of light. The night sky is not synchronized. It is a collage of different eras layered into one view. Your brain resists this at first. It wants the sky to be now, to match your experience of the ground beneath your feet. But science insists gently. Observation always lags behind reality. Light takes time. This does not make the sky deceptive. It makes it honest. Silence is also a kind of data. When astronomers study stars, they study history. Spectra reveal temperatures, compositions, and motions from long ago. Changes observed today reflect processes that already unfolded. Knowledge arrives late, but reliably. This delay has profound implications. Some stars you see tonight may no longer exist. They may have exhausted their fuel. They may have collapsed. They may have exploded. If that happened after their light began its journey toward you, you would not know yet. This idea often sounds unsettling, but it is not dramatic. It is simply a consequence of distance. The universe does not update observers in real time. The absence of information does not mean absence of events. It means the signal is still on its way. Numbers whisper more than they speak. For Betelgeuse, this uncertainty is real. Astronomers know it is nearing the end of its life. They know it will eventually explode as a supernova. They do not know when. The explosion could have already happened, or it could occur far in the future. If it happened recently, its light has not reached Earth yet. When you look at Betelgeuse, you are looking at a star that may already be gone. This is not tragedy. It is perspective. You are accustomed to thinking of history as something written by people. Documents, stories, memories. The sky offers a different kind of history. One written in photons. One that arrives slowly and without interpretation. Space rarely gives us simple answers. This temporal distance also reshapes certainty. On Earth, you trust your senses because feedback is immediate. In astronomy, certainty is always provisional. It depends on how far away something is and how old the information might be. Yet this uncertainty does not weaken science. It strengthens it. Astronomers account for delay. They model it. They accept that knowledge has boundaries. Silence is also a kind of data. When nothing changes in the sky, that stability tells a story. When something changes, the delay tells another. The universe communicates not through urgency, but through consistency. From a human perspective, this can feel humbling. You realize that the present moment you experience is not shared by the cosmos. The universe does not align itself to your now, and yet there is something deeply calming about this. The stars are not watching you. They are not responding to observation. They simply exist following their own timelines, indifferent to being seen. You are the one receiving their past. This reframes the act of looking up. Stargazing becomes listening, not for answers but for arrivals. Each point of light is a signal that has traveled patiently across space, uninterrupted, unaffected by events along the way. Numbers whisper more than they speak. The night sky is not a mirror. It is a record, a collection of stories told at the pace of light. Some are recent, some are ancient. All are incomplete. As you rest with this idea, the stars lose urgency. They do not demand interpretation. They do not rush toward meaning. They simply arrive. And in that quiet arrival, you begin to understand that seeing the universe is not about witnessing what is happening now, but about accepting the long, gentle delay through which reality reaches you. When you leave the sun behind, distance changes again. The nearest star system to Earth is Proxima Centauri. It feels close by cosmic standards. It belongs to the same small neighborhood of the Milky Way. Astronomers describe it as our closest stellar neighbor, a quiet red star orbiting a pair of larger suns. Yet Proxima Centauri is more than 4 light-years away. This means that even the nearest star lies beyond anything humans have ever reached or are likely to reach soon. The light arriving from Proxima Centauri tonight began its journey before recent memories formed. Distance here no longer suggests travel. It suggests separation. Space rarely gives us simple answers. On Earth, proximity implies possibility. If something is nearby, you assume you could reach it with enough effort. Among the stars, this assumption fails quietly. 4 light-years does not feel large when spoken aloud. But when translated into travel, it becomes overwhelming. Human spacecraft move slowly compared to light. Even the fastest probes ever launched travel at a small fraction of 1% of light speed. At those velocities, reaching Proxima Centauri would take tens of thousands of years. This is not a failure of engineering. It is a reflection of physical limits. Propulsion requires energy. Energy requires mass. Mass resists acceleration. Each increase in speed carries an exponential cost. Space does not punish ambition, but it does not reward shortcuts either. Numbers whisper more than they speak. Voyager, which has traveled for decades, has not yet reached a single light day from Earth. It remains close by stellar standards, moving patiently through the outer edge of the sun's influence. Its journey is remarkable, yet deeply local. This contrast reveals an uncomfortable truth. Interstellar distances are not extensions of planetary distances. They are a different category entirely. They do not scale gently. They jump. Between stars lies not empty space to be crossed, but time that must be endured. Silence is also a kind of data. This is why interstellar travel remains theoretical. Not impossible in principle, but constrained in practice. Physics allows motion through space. It does not promise arrival within a human lifetime. Projects like Breakthrough Starshot acknowledge this reality. The concept is simple in outline and challenging in detail. Tiny, lightweight probes would be accelerated by powerful lasers to a significant fraction of the speed of light. They would carry minimal instruments and no crew. They would not slow down upon arrival. They would pass through another star system briefly, sending data back if possible. There is no promise of exploration in the familiar sense, no landing, no return, only a flyby and a signal. This idea is not science fiction. It respects known physics. It does not assume breakthroughs that violate natural limits. It is careful, restrained, and realistic about uncertainty. Space rarely gives us simple answers. Even at these ambitious speeds, travel times remain long. Decades would pass before data returned. The people who launch the mission might not be the ones who receive its results. Exploration becomes an intergenerational act. This is a quiet shift in perspective. Human exploration has always relied on presence. You go somewhere, you see it, you return. Interstellar space removes this pattern. It replaces presence with patience and direct experience with delayed knowledge. From a scientific standpoint, this is acceptable. Data does not require a human witness. Instruments do not mind waiting. Signals do not age emotionally. From a human standpoint, it feels distant, detached, less personal. Numbers whisper more than they speak. The vast distances between stars force you to accept that the universe is not arranged for travel. It is arranged for observation. Light moves easily. Matter does not. This asymmetry defines cosmic exploration. You can see far, you can learn much, but you cannot easily go. Silence is also a kind of data. Between stars, there are no roads, no markers, no gradual transitions. Just long stretches of near emptiness punctuated by isolated systems. The galaxy is not crowded. It is sparse. This sparseness protects stability. Stars do not collide often. Planetary systems evolve quietly. The universe favors longevity over accessibility. As you rest with this idea, distance between stars begins to feel less like an obstacle and more like a boundary that shapes meaning. It reminds you that knowledge does not always require presence, and that understanding can arrive without movement. And in that acceptance, the nearest stars become not destinations to reach, but reference points that quietly teach you how large the universe truly is, and how patient it expects you to be. As distance grows, time begins to behave differently. In everyday life, time feels shared. Clocks agree, moments line up. You assume that what happens now for you happens now everywhere else. This assumption works on Earth because speeds are slow and distances are small. The universe quietly allows the illusion. When motion becomes fast, the illusion fades. Physics reveals that time is not absolute. It stretches and compresses depending on how you move. This effect is called time dilation. The name sounds technical, but the idea is simple. Moving quickly changes how time passes for you compared to someone who remains still. You do not notice this in daily life. Cars, airplanes, even rockets move too slowly for the difference to matter much. But the effect is real. It has been measured repeatedly using precise clocks. Time aboard fast-moving objects passes slightly more slowly than time on Earth. Space rarely gives us simple answers. This means that speed carries a cost, not in fuel or energy alone, but in synchronization. The faster you move, the more your time drifts away from the time of those you leave behind. There is no drama in this, no sudden jump, just a steady divergence. If you could travel close to the speed of light, the difference would become significant. A journey that feels short to you would last much longer for everyone else. You would age more slowly relative to the rest of the universe. Upon return, you would find that time has passed unevenly. This is not science fiction. It is a consequence of how space-time is structured. Numbers whisper more than they speak. The universe enforces this rule without exception. You cannot move faster without paying the price in time. Speed and time are linked. You trade one for the other. This connection reshapes how travel must be understood at cosmic scales. Going fast does not simply shorten journeys. It reshapes the relationship between traveler and destination. Arrival no longer means reunion in shared time. Silence is also a kind of data. Even without formulas, the consequences are clear. There is no universal clock that everyone agrees on. Each path through space carries its own rhythm. Each observer experiences time differently depending on motion. This is deeply counterintuitive. Human experience teaches that time is constant and shared. Physics reveals that it is flexible and local. The universe does not offer a preferred pace. This flexibility ensures consistency. It preserves the speed of light as a limit. It prevents information from arriving before it is sent. It maintains causal order. Without time dilation, the universe would break its own rules. Space rarely gives us simple answers. For interstellar travel, this effect matters. Even hypothetical journeys at extreme speeds would isolate travelers not just by distance, but by time. Communication would stretch. Synchronization would fade. Shared experience would dissolve. This is a subtle barrier. It does not block movement, it transforms it. Travel becomes not just a matter of where you go, but when you belong. Numbers whisper more than they speak. Time dilation also reframes observation. Astronomers already look into the past because light takes time to travel. Motion adds another layer. Observers moving differently experience events on different timelines. There is no single version of now that applies everywhere. This realization can feel unsettling, but it is also stabilizing. It means the universe is consistent from every perspective. No observer is privileged. Each experiences reality according to the same rules, even if the outcomes differ. Silence is also a kind of data. The cost of moving fast is not punishment, it is balance. The universe allows motion, but it preserves structure. It allows exploration, but it maintains order. At human scales, these effects remain invisible. Life unfolds smoothly. Clocks agree. Days pass together. The universe does not intrude. At cosmic scales, the rules assert themselves gently. As you rest with this idea, time becomes less rigid. It feels less like a ticking background and more like a dimension you move through. One that stretches with speed and settles with rest. And in that understanding, it becomes clear that distance is not only measured in space or light, but also in how time itself shifts to accommodate the journeys you imagine, quietly reminding you that going faster always changes more than just where you arrive. You begin close to home, among familiar stars. The Milky Way is your galaxy, a vast rotating disk of hundreds of billions of stars bound together by gravity and time. From the inside, it feels endless. Its spiral arms stretch across the sky. Its center glows faintly through clouds of dust. Every star you have considered so far belongs to this single structure. Yet even the Milky Way has edges. Light takes about 100,000 years to cross its full diameter. This means that the galaxy you inhabit is already a layered object in time. When you look toward one side, you see a different era than when you look toward the other. The Milky Way is not a single moment frozen in space. It is a slow conversation between distant regions, each responding late. Space rarely gives us simple answers. Beyond the Milky Way lie other galaxies, billions of them, each one its own island of stars, gas, and dark matter. They are not arranged neatly. They form filaments, clusters, and voids, large-scale structures shaped by gravity over immense spans of time. At this scale, distance stops feeling like separation between objects and starts feeling like the shape of the universe itself. The observable universe extends about 93 billion light-years across. This number is not intuitive. It is not even a simple distance. It represents the farthest regions from which light has had time to reach us since the universe began expanding. Numbers whisper more than they speak. This does not mean the universe is only 93 billion light-years wide. It means that light from anything farther away has not arrived yet and may never arrive at all. Observation is limited not by curiosity, but by time and expansion. The universe is expanding. Space itself stretches. Galaxies are not moving through space away from one another. Space between them is growing. This expansion carries distant regions away faster than light can cross the increasing distance. This does not violate physics. Nothing locally moves faster than light. Instead, the structure of space changes. Distance increases without motion. Silence is also a kind of data. Because of this expansion, there is a boundary called the observable horizon. It marks the limit of what can ever be seen. Beyond it, events occur that will never affect us. Their light will never reach Earth. Their existence is inferred but not observed. This horizon is not a wall, it is not an edge you could approach. It is a consequence of cosmic timing. A reminder that the universe has a history and that you exist within a specific chapter of it. Every observation you make is constrained by this horizon. Every galaxy you study lies within it. Everything beyond remains forever unknown, not because it is hidden, but because time is finite. Space rarely gives us simple answers. The observable universe is not a map of all that exists. It is a record of all that has had time to communicate with you. It is shaped by the age of the universe, the speed of light, and the expansion of space itself. This perspective removes the illusion of completeness. Science does not claim total access. It claims careful attention within limits. Numbers whisper more than they speak. At this scale, the human element returns quietly. You are not standing at the center of the universe. You are not special in location. Every observer, anywhere, sees their own observable universe centered on themselves. Each horizon is local. This symmetry is not poetic. It is physical. The universe does not arrange itself around viewers. Viewers simply receive what arrives. Silence is also a kind of data. Beyond the observable horizon, there may be more galaxies, more stars, more complexity, or something entirely different. Science remains honest about this uncertainty. It does not speculate without evidence. It waits. The universe does not rush answers. It releases information slowly, as expansion allows. As you trace this path from nearby stars to distant galaxies, from the Milky Way to the edge of observation, a quiet pattern emerges. Distance has transformed again. It is no longer about travel or delay or even history. It is about limits. Not limits imposed by weakness, but limits woven into reality itself. The observable universe is not small. It is vast beyond comprehension, and yet it is only a portion of what exists. A portion defined by time, patience, and the steady pace of light. As you rest with this idea, the scale no longer presses inward. It opens outward. The universe does not feel crowded with meaning. It feels spacious, orderly, and calm. And in that calm, you begin to understand that knowing the universe does not require seeing everything, only accepting how much has already arrived, and how much will always remain beyond the horizon, waiting in silence. You return gently to where you began, not to the vastness itself, but to your place within it. After traveling from familiar distances to the edge of the observable universe, nothing about your physical surroundings has changed. You are still here. The room is still quiet. Your breath still moves at its own calm pace. And yet, something subtle has shifted in how distance feels. You have seen that space is not designed for immediacy. That information takes time. That light carries history. That even the nearest stars speak to you from the past. Space rarely gives us simple answers. This is not meant to make the universe feel cold or distant. It is meant to make it honest. The universe does not rush to be understood. It unfolds at a pace set by natural limits, not by human expectation. You live inside those limits every day. You wait for light to arrive. You wait for signals to return. You experience a present that is quietly stitched together from many different pasts. Numbers whisper more than they speak, and within that waiting, meaning appears. Science does not remove wonder, it reshapes it. Distance stops being something to conquer and becomes something to respect. Time stops being a background and becomes part of the structure itself. Silence stops feeling empty and starts feeling informative. Silence is also a kind of data. In this way, the universe invites a different relationship. One based not on speed but on patience, not on control but on attention. You are not asked to understand everything, only to notice what has arrived. As you rest now, the vast scales no longer press inward. They expand outward, leaving space for calm. You are not small in a hostile universe. You are part of a universe that moves carefully, consistently, and without urgency. And perhaps that is the quiet lesson carried by all this distance. That understanding does not come from reaching the end, but from learning to listen as the universe takes its time reaching you.